In this video, I want to explain graphs. What is a graph? How it be represented? So, graph is one of the non-linear data structure which is used to make the relation among the some complex information, just like some network information, otherwise in hierarchical relationships. So, to represent the relation among the elements having more than one predecessor and successor. Okay, so a network, otherwise some hierarchical relations among the data elements. And basically a simple example we can take in a Facebook, a person having the account. So each person is represented a node, nothing but a vertex. So vertex, what is that? That we will be discuss just later. And which contains nothing but the node contains particular person's details. So every node, nothing but every vertex, otherwise if every person in the Facebook account, he will have the communication with the remaining his n number of friends. So it is very helpful, because if you want to make the relation among more than one predecessor and succeeders, before in the trees we have one right child, other left childs. So like that we have the communication among the childrens. Here if you want to make the more communication among the more data elements, it is possible with the help of the graphs. Okay, how the graph will be represented? You know how the tree will be represented, how the hierarchical representation, parent, left child, right child, again subchild, subtree, right child, subtree, left child, subtree, like that. Here the graph will be represented like this. How it be represented? Look at that, it is looking like a graph. So a graph, here we can say it is a graph G having V number of vertices and E number of edges. Here V nothing but number of nodes, otherwise our data elements, and edges stands for how the vertices are connected. So how many edges are having nothing but how many edges are stands for the communication, otherwise the relation among the vertices. Okay, here what are the edges here? So an edge between A and C, and edge between AB, and an edge between C and D, and the edge between BD and BE and DE. Like that in the video we can see at the down, the vertices V is A, B, C, D, and edges are AB, AC, BD, BE, CD, DE. Like that we can represent a graph. Here in the graph we can see that A is communicate with the C and D. At the same time B is also having the edge to the D and E. So if you have the more than one predecessor and succeeders, this will be represented with the help of graph. Even though it is a very simple graph, even a vertex is communicating itself also. In graphs also we have two types. One is a directed graph and another is undirected graph. So here what we have seen here, this is undirected graph, because there is no direction among the vertices. So if A is directed to B, nothing but the arrow symbol is represented, that is called as a direction. So if the graph having the direction between the vertices with the edges, so directed graph, that is the directed graph. So here what we have, what you are observing, that is the undirected graph. Okay, so what are the entities? We have the different entities for the graphs. What are those? Basically we have to create a graph. How to create? We have to insert a vertices, and we have to insert edge among the vertices. We have to delete a vertices, otherwise delete an edge. These are the different functions to make a graph. And we have to check that one more function, that ADD is empty. Suppose if the graph having any vertices or not, any edges are not among the edges, among the vertices. Okay, so for insert vertices we have the graph G and V number of vertices, and delete vertices stands for having the graph and number of vertices. Like that we have every ADD functions having the graph and V number of edges. Here what is create function? This create function used to create an empty graph. So empty graph nothing but we don't have any vertices and edges, nothing but vertices and edges, V and E are null set. So how many number of vertices and edges if you are creating a empty graph? 0. So V vertices and edges are 0. total number of vertices and edges are both at 0. In the next ADT, in the insert vertices function, this function is used to create, otherwise insert a vertices vertex, not vertices, insert a vertex into your graph. Here look at the diagram. Here A is represents ABC is a graph of having 3 vertices and 3 edges. So if you want to add a vertices, what is that? D. In the diagram B, we can see that D is a new vertices is inserted. So if you have to make a connection with the edge, then how many edges are there? So let us see the diagram C. In that we have the vertices are, total number of vertices are 4. How many edges we have? AC, AB, CB and BD. So these are the different vertices and edges. So if we can insert a vertices and make the connection with the edge, then the resultant graph having the added new vertices and different number of edges. Here how to delete a vertices. So next ADT is deleting vertices. So the diagram here represents a graph having ABCD and communications are edges are AC, AB, CB and DB. Okay, these are the edges. So if I want to remove C vertices, the resultant is represented in B diagram AB, BD. So number of vertices are A, B, D, and how many edges are there? 2 edges, only 2, because C is removed. The edges among the A and B communicate to the C, nothing but the whatever the edges are connected to C with the remaining vertices are removed. So if the vertices is removed, the edges also will be removed, nothing but deleted. So the resultant graph having the 3 vertices and 2 edges. So those edges are AB and BD. How to insert A and H? So before that we seen one thing, that while we are inserting a vertices, we have to insert a edge also. Then only the, so here we have inserted a vertices. So if you are not having any edge with the remaining existed graph, so that inserted vertices is looking like an isolated vertices. So while you are inserting a vertices, so we have to connect nothing but with an edge is connected to the existed graph. So here the diagram D having connect edge, having an edge. Before that, that is looking like an isolated. So like that, while we are inserting a vertices, we need to insert an edge. So how to insert an edge? Here we are inserting an edge between the graph, between the vertices. Here that is first diagram is A, represents A, B, C, D. Here C, D are not having any edge. Here we are connecting the an edge between C and D. So before the graph, A represents A, B, C, D are vertices. Edges are AB, AC, BC and BD. After that, an edge is connected with the C and D. The resultant graph having the 4 elements, same 4 elements. Before we have 4 vertices, and now the one more edge is added, that is CD. How to delete an edge? We can delete an edge. So if you are delete an edge, that deleted edge is making a node, otherwise a vertices will be as isolated. Then making any node making n with a isolate, it might be or not, it may be take the isolation or not, that depending upon the edges between the particular deleted edge vertices also. Here the diagram A represents A, B, C, D. Okay, the edge is removed between B and D. Edge is removed between B and D. So doing D having no communication with A and C, no edge between A and C. So D is isolated. So the total number of vertices are, after deleting an edge, A, B, C, and how many vertices edges we have? A, B, B, C and C, B. So D, so that connection with the B and D are removed. The edge is removed. So we don't have the edge between the B and D, even with the C and D also. So D is an isolated element, vertices. Next, empty graph. E is empty. We are checking the E is empty graph. So E is empty is a function. One of the last function of the graph, ADD of graph is E is empty. Suppose at first we have created an empty graph, nothing but no vertices and edges. So total number of vertices and edges are 0. Okay, null set. Here also we have to check that whether a graph is empty and returns the true if empty, otherwise returns false, because if graph is not empty, it will represent false. If it is empty, it returns true. Okay, so an empty graph is one which the set V is a null set. We already know that while we are creating a graph, we have V and E, nothing but number of vertices and edges are 0. Like that, here empty set, nothing but if it is true, it returns that we have no vertices. So if you are not having vertices, so we doesn't have edges also. Next, how can we represent? So this representation needs the matrices format. Matrices representation, you know the matrices representation. So you already know one thing, that we have the directed graph and undirected graph. In the directed graph, so one edge is connecting to the directed to the particular one more other vertices. One vertices is directed to particular vertices. So a vertices will be having the number of edges with the remaining vertices also. So first one we have to know one thing, that directed graph and undirected graph. Look at first adjacency matrix representation. So here look at that. While we are representing a undirected graph, so the A, B, C, D, E are the undirected graph. In the graph containing the matrices of size, how can we represent a matrices? Here the matrix is having the size of the total number of vertices by total number of vertices. Nothing but how many vertices we have? 5. So here the matrices is 5 by 5 matrices. So how many 5 by nothing but 5 rows and 5 columns. So what are the rows here? Vertices, and columns also vertices. So how can we represent in the matrices? Adjacency matrix representation. Here look at the diagram is the matrix representation with the 0 and 1. So where we have to represent 1? So here we have to represent 1. There is an edge from one row vertices to the column vertices. One row vertices to the column vertices. Suppose look at that, A is a row and B is A is a column. At first initial value, it is represented 0. Nothing but 0 represents no edge between row vertices and between the row vertices and column vertices. So first look at that, A to A is 0. Why? Because so A doesn't have an edge from A, because it is also making 1, because in case if it is a self looped, we can represent 1. It is not self looped, that will be discussed in later. And here A to A row and A column represent 0, because there is no edge between A and A. But we have an edge between A and B, A row, B column. So the next value, so first row, second column value 1, that represents A row, nothing but A, B represent 1, that is nothing but A row, B column having 1, nothing but then there is an edge between A and B. And so next value 1, nothing but AC. There is an edge between A and C. Look at that, all the values will be represented in the 1 and 0. 1 stands for edge having between the vertices. So if there is no edge between the particular row and column vertices, that is 0. So this is the undirected graph representation. If we have the directed graph representation, see that we have to represent if there is a direction between the vertices to the other vertices. Here a direction between A to B, that is 1. So A to C is 1, and A to D having the edge? No, it is incoming direction, so that we have to represent 0. So if there is a direction between the one vertex to the another vertex, that is 1. Otherwise the remaining cases we have to represent with the 0. So look at the last one, E row and remaining A, B, C, D columns. So E with the A, so no direction. E with the B, no direction, 0. So like that all the values of the matrices, directed graph, all the zeros, nothing but it's a directed graph. Before that we have the communication with 1 0 1 0 with the E2 remaining columns. So because this is a undirected graph, here this is a directed graph. I think we can understand what is the directed and undirected matrix representations. Incident matrix representation. Next one, incident. See that here the matrix representation can be done by the, what is the size here? The size is the total number of vertices by total number of edges. Okay, total number of vertices by total number of edges. So how many vertices we have here? 5. 5 by how many edges? 3 4 5 6 7. 7 edges. So that matrix is 5 by 7 representation. Look at the matrix representation A, B, C, D, or the rows from edges E1 to the A8. These are the edges. So how can we represent? The representation is different with the above representation. Before representations, nothing but 0, 1 representation before in the adjacency matrix representation we learned. But here 1, 0 and -1. What is that? Here 0 represents row edge is not connected to the column vertices. Here A to B having the connection, nothing but E1 is a, look at that column, E1 is an edge from A to B. So look at E1, A row E1 is 1. Okay. And next A to E2, from A E2, nothing but E2 having connection, yes, 1. And E3, look at, it is a -1. E1, A row E1 column, -1. Why it is? So A2 E3. E3 is having the incoming direction. So that we have to represent in -1. So before that, instead of -1, we have represented 0. So if it is not 1, nothing but we are represented 0. Directed graph also. But here we have represented -1 stands for the direction is from incoming, like that. So here 1 represents row edge is connected as outgoing edge to the column vertices, and -1 represents row edge is connected as incoming edge to the column vertices. So 0 you can understand, not having any edge. -1 stands for incoming edge in the directed graph. So how can we represent with the adjacency list? Adjacency list. What is that adjacency list here? So look at the diagram, that graph. So A, B, C, D, E. So one thing you have to know, that D having self loop, that is one more edge E8, one more edge E8. So okay, here the graph is represented, self loop D has. So look at the list representation. You know the list, linked list we have. So every node having the one is data part and list part, nothing but link part. The link stands for other list is connected to the existed list. Other link is connected to the existed list. So other address of the node is connected to your existed node in the list part, list block. So A is having the connection with the A and C. So representation of A is B and C, and before D and E. See that directions are B and D. So not E and not E with A, and C having connection with the D. Okay, C D. Next C having with D, and D having A D E, and last E doesn't have any self loop. In the D we can understand it is having self loop. So and A is with the incoming direction to the A, nothing but A is directed to A and directed to D also, and directed to E. And E it doesn't have any directions, and even though it doesn't have the self loop. So this is the list representation. At the second one, it represented in the array. Represented in the array. How can we represent it in the array? By using the graphs. Here we can see A, B, C, D. So and E. So these are the graph, and 0, 1, 2, 3, 4. From 0 to 4, nothing but 5 elements. 5 nodes are there. Nothing but 5 vertices. So A is with the B and C. See that A, B, C. Okay, B, C. And B having the D and E vertices, and C having the D vertices, and D having self loop. A with D, D with D and E, and D doesn't have any direction because this is a directional graph. So adjacency array we have represented. So this representation, these are the three representation. One is incident, one is the adjacency matrix representation, incident matrix, and last one we have just now learned, that is adjacency list. So these are the different representations. Last one, these are very important. Just I want to introduce the traversals. What is the traversal here? Traversing nothing but visiting the existed data elements in your data structure. Here our data structure is graph. So here traversal is used for searching a vertices. What we have to do? We have to search an element, nothing but vertex from the graph. So in a graph, and traversal is also used to decide the order of vertices to be visited in the search order. Which order we are going to search? So we can come to a conclusion to decide the order of the vertices to be visited in the search graph. There are two traversing techniques, depth first search and breadth first search. So all these will be discussed in the next session. Up to that, we learn what is a graph, how can be represented, and how the matrix representation, adjacency matrix, and incident matrix and adjacency list, all these will be we have learned these things here. In next we will discuss about what the traversing techniques. Okay.